Hi guys, welcome to Finance Chanakya. This is this. In this video, we are gonna learn all about theta, how theta measures the option sensitivity, etc. So let's get started. Coming to theta, theta is an option sensitivity measure. It measures the value of our call option or a put option to change in time. Value of change in value of call or put option to change in time. It is termed as time decay of an option. So it is theta is denoted by change in call price delta C divided by delta T. So call option is given by the formula minus stop price into ND1, which will be given by the formula ND1 will be given by 1 by root of 2 pi into e raised to minus x d square d1 square. If it is d1 square by 2 minus r is our risk-free rate into strike rate into e raised to minus rt risk-free rate into time is given in number of years, so n into d2. Put is also calculated by using the formula. Just change our signs minus and plus here. You just keep it minus and change to plus, and there is minus d2. That is only change that happens because minus d2, just because in a normal distribution, if you see, suppose, so here everything is minus, so put option will lie here and call option will be here, so minus in d2 will be in this part, so that's why it is minus d2. So this is how we calculate the value of theta. So if you come to the graph, so as a value, theta is always expressed in a negative, and as the stock price increases, theta value increases a little bit in absolute terms, and then it goes down and then it stabilizes. So for if you plot theta against time until expiration, so as stock price increases, the value of theta goes down in a convex manner. So convex to the origin, so it will be going like this. So this is how it works. Theta works. This is the formula that we need to remember, so and apply. So let us take an example and explain how it works in actual sense. So suppose the stock price of XYZ is trading at 50, call option trades at XYZ, exercise price is 45, expiration 3 months, risk free rate 5%, standard deviation 12%, that is next like volatility. So determine the value of call option theta per trading day. Assume D1 is equal to 1.99 and D2 is equal to 1.93. So the normal probability tables, ND1 is 0.9767 and ND2 is 0.9732. So these things are given, and we don't need to calculate all these things. So N bar D1 will need to calculate. So 1 by root of 2 pi into e raised to that same formula, e raised to minus d1 by 2, which gives us 0.055, and the call option can be calculated using our formula S0 into n dash d1 into 0.12 divided by 2 into 0. That is t minus 0.05 into which is sigma, and 45 is the strike price. E raised to rt is a risk-free rate. This risk-free rate, and this risk-free rate into t. Time is 0.25 because it is in years, and 3 months is all needed. 3 by 12. If you see 3 by 12 is equal to 0.25. This is nothing but ND2. If you see here, one thing that we need to specifically remember is, don't use nd1 here because nd1 is not gay, it is n dash d1. nd1 will be calculated while the same formula, using the same formula that we calculated our call option value. We'll use to calculate our call option value using Black-Scholes-Merton model. So same way they have calculated in given nd1 and nd2, but that is not the formula we used to calculate n dash d1. This is the formula we use. So n dash d1 is used here, but here it is nd2, so that needs to be taken care of, which gives 0 minus 2.49. so the thing is that this is for a total year because we have converted our time into year, 0.25. so bringing it back into number of days, we'll have to divide it by number of trading days, which is not 365 but 252, because number of trading days in a year is much lesser than the number of actual days, since the thing is that we will not be trading Saturdays, Sundays and holidays, etc. So 250 is assumed and it is close to minus 0.00980. So always remember theta will be negatively. So that is one thing. So that's why we plot the graph in a negative manner. So that's how we calculate, that's what theta is. Coming to specific characteristics of theta, this has already been explained to you in previous slides, but let us check this out. So theta affects the value of put and call in a similar way. Time passes, most call and put will decrease in value, else equal. So that's what both of them does, because as I have shown you, the value of theta decreases, then it gets stabilized. So theta varies with changes in stock price as time passes. Quite common. Theta is most pronounced when the option is at the money and especially near to the expiration. So okay, correct. So that is being given in that what do you call that graph itself. Theta varies, values are usually negative, which means the value of the option decreases as it gets closest to the expiration. Quite common, whenever it gets closer to the expiration it will reduce, so it will be negative. So theta usually increases its absolute value as expiration approaches. Okay, so it is possible for a European put option. That's this point is explained to in that graph. Like, see, we have seen a convex. So this is how the time passes. This is how the time passes. So since the expiration, the value of theta will be high. So that's all. So is if it is possible for European put option that it is in the money to have positive theta value. So positive theta value is possible for a put option, since the first part of that equation can be more than the second part, because second part can of the equation can be more than the first part for the put option. That can be only explained if you do a problem in that using put option. The put value, if you see that equation of put, so the second part is positive and say first part is negative, the second part can be more than the first part. That's what being explained in the last point. So that's all the specific characters. Hi guys, thanks for watching. If you like my video, like, share and subscribe. If you have any suggestion, comment. Thank you, thanks for watching.